Hello, my name is Jason Easted. I'm an engineer here at MapleNet Wireless. Today we're going to be going through the basic configuration, setup, and some basic features of the Ceragon IP10 platform radios. In order to log in the radios, you will first need to set an IP address on your computer that is on the same network as the IP10 radios. The default IP address for the IP10 radios is 192.168.1.1, and that can be accessed only through the NMS port here, which is located on the front. If you have lost or misplaced, or you do not know the IP address for the Ceragon IP10, you can also access the radio through the serial port on the front of the radio. The port setting for that would be 115200 baud. We will begin with a pre-configured radio. That way we can share the statistics of the live network. First, we will log into the radios. The default username and password of the radios is admin and admin. This will give you unrestricted access into the radios for full configuration of the IP10 platform. We'll start at the top menu here under Configuration. Configuration, I open the tab Configuration, then I go to General. From here you can specify unit parameters. Unit parameters specifically defines the name, the contact person system location. You can define the measurement system, either metric or imperial. You can also set the offset for the GMT. We use this for the NTP. If you have an NTP that is on Green Mountain time, then you can actually define your offset for that. You can also view the IDU and RFU serial numbers here in this location. You can configure the external alarms in the radio by clicking a plus sign and either enabling and changing the text. You can also set the severity of the alarm. These alarms are designed to be used for door alarms, sensors, other devices you may have at your location. Management. Management is what it sounds like. It is the local IP address and local management of the radio. This is where you set the IP address where you can log into the web page. You can define how many ports you'd like to use for management. You can also define if it is in-band or out-of-band management. Out-of-band management basically is management that is only on the management side, is not through the radio traffic. In-band is management passed across the radio traffic. Traps configuration. Traps configuration can be defined as outgoing traps that can be received from a trap server or some form of trap relay. First, you define the trap manager, define the port, and you also can define what types of traps you would like to have, either indeterminate, critical, major, warning, cleared, or you can just select them all and receive all traps. By default, no traps are enabled. Licensing. Licensing on the radios can be purchased through Ceragon or through a VAR that allows you to do several features. You can do ACM, you can do metro switching, or you can just do Ethernet switching. Also, licensing will also control the speeds and performance of the radios. NTP. NTP is a time server, where you define the time server. The NTP server is simple as defining the time server and enabling it. SNMP. SNMP is the community string that is defined to pull public and to write private information to the radios of the IP10 platform. Versions. If you go into versions here in the ID, you can actually see the current running software version of the radio. You can also see which package can be upgraded and downgraded. Currently, we have no downgrade packages because it is just an initial release. You can also do the same for the outdoor unit. Ethernet switch. Under the switch configuration, you can define what application type you want. Single pipe, managed switch, or metro switch. Single pipe is a single dedicated pipe trunked straight across between the two radios. It is completely transparent and is designed for a direct connection on a network. Managed switch is much like the Cisco design. You can implement VLANs as well as trunked ports and devices like that. It turns the entire front port of the radio into a managed switch. Metro switch is something proprietary to only Ceragon. Ceragon allows you to create a metro tunnel on individual lines that you can pass through that completely do not interact with each other across the link. The metro design is well used if you have several individual customers you can use. You can create customer networks and provider networks, and you can actually separate them where their traffic does not touch, and it keeps them very secured and separate. Radio parameters. Under radio parameters, you can enable the frequencies defined by the FCC on the radio. If it's a licensed radio, it can be defined here. Unlicensed, you can set them manually. You also can set the transmit level as well as mute the transmit or enable the interface in this location. Up here you can see the signal level as well as the defective blocks through the link. Remote radio. Here you can see if the remote communication is physically passing traffic as well as the remote IP address. Signal level is also included here, as well as you can see the transmit level on the remote side. This field is adjustable from here. You also, if the remote radio is muted, you can actually unmute it from this interface. MRMC. This is called the multi-rate multi-constellation. This is basically the speed of the radios as well as the channel bandwidth that it's using. This also will be defined for you by the FCC. If you look here, we have it licensed all the way open, but you can actually come down here and define adaptive, fixed, or speed, and you can actually define the maximum speed as well as the minimum speed in this location. ATPC, Automatic Transmit Power Control. This here is usually not used under FCC, but it is capable of doing it. You can actually control the amount of signal level received from the radio through this, and it'll actually adjust the power accordingly. Interface. Ethernet ports is where you can actually edit, select, and change the type of Ethernet ports you have and how they are used. In this case, we're running a single pipe mode. We currently do not have any traffic across this link right now. It is in this test bench situation, but you can actually enable the port, and it is capable of being an optical or an RJ45 port. These ports are not designed to work together. You can only use the optical or the electronic port. You can't use both at the same time. You can also add automatic state propagation. State propagation, basically if the link fails, will disable the Ethernet port. This is good environments where you have a need for a port to physically go down to enable redundancy in some form. Now we'll begin our troubleshooting section. Whenever there's an issue with the link, these are some of the steps we will take from MapleNet Wireless perspective to troubleshoot and potentially repair a link through the software. We'll start at the beginning here, under faults. The first thing we like to look at is current alarms. We can see if there's any alarms in the radios. This will give us a fair assessment on the type of problems we're having. Currently there are no alarms because this is on a bench, and it should be working very well. We will look through the event log. A lot of these logs were from the reboot. You can see here RFU reset. We have a couple low signal RFU where we had made some changes when we initially did the setup. This is common when you start a new one. You'll see cable open in events like that. You'll want to be looking for errors such as RFU communication fail, loss of frame. Errors like that can cause packet loss and cause problems. This event log can be tracked back as far as 100 events. So beyond that, it will actually stop logging and you have to log it to a log server. Okay, we'll move on down here to PM encounters. Basically here, this is where you can view the signal level for the current day, as well as you can view it over time. This will hold up to 30 days of logging in this daily report here. Currently, we only have a couple hours of information, so you can actually see here the integrity on the right are actual events that we can count on that were legitimate events in the logs. Aggregate errors. This is a report basically that generates errored seconds, severely errored seconds, BBE errors, and these errors are very significant if there's issues in the link, which could be causing performance problems. This should essentially be 0 at all times if it's a good performing link. MRMC, you can see the maximum and minimum profiles that the MRMC was transmitting at. As you can see here, most of the time here it's been at full profile, but if you're having issues with the link, these numbers can change and you will see some problems between the two of them sometimes. That's a good way to troubleshoot by looking at that. You can also actually go down here and look at the throughput of the link here. You can actually see the amount of traffic going through. As you can see, our link here doesn't have a lot of statistics, but you can actually deliver this information to a customer, and it's fairly accurate on the kind of throughput that's going through the entire radio. Now keep in mind, this traffic is through the wireless radio and does not include any T1 interfaces that may be on the radio in this information. Okay, One last test here when we get to the point, if we're having real big issues, is called a loopback test. The loopback test basically is a test that puts the radio into a loopback state, which allows you to physically test to the radio without going across the link, or to the outdoor unit without going through the link. So you can see here it's defined as RFU, RF loopback. You can define that and then specify a time. If you leave the time at 0, it will not shut off. By default, timeout is 1 minute, but it can be defined to whatever you prefer. We recommend putting it for at least 60 minutes to do a thorough test, and you can do this either on the RFU or the ODU. Once the radio is in loopback, the way to test and verify for errors, there's 2 ways. First, you go to PM encounters, radio, and then aggregate. From there, these counters here should maintain 0 if you have an error-free loopback. If the numbers are counting up, you have a fault either in your line or on your RFU if you're testing to the RFU, or you have a fault at your IDU. We prefer that you test both when you find the error on the first one. The other way to test is you can actually see under configuration, radio parameters, you can actually see if this here, if the defected blocks on the radio parameter is counting up. If that is counting up, you do still have issues and you need to review your problems. Thank you for watching our Ceragon IP10 training video. Hopefully this will assist you in your future setup and troubleshooting of an IP10 Ceragon radio link. If you have any further questions, please contact us at 877-MAPLE-01. Thank you.